What's up, math scholars? Mrs. Harp here, coming at you with another video. Today we're doing 1.4, day 2. We'll still be factoring using the AC method, but now we'll be solving those equations. Who's excited? Woo! Yeah. I don't know if you look at the dates I record these things, but it's currently July 11th. So hope you're having a good summer break. All right, first things first, since we will be equation solving today, just a refresher on the vocab. If I would use the word roots or x-intercepts or solutions or zeros, those words are interchangeable and they all mean the same thing, and that is the solution point of parabola. So what visually this looks like is that's a solution point. That's a solution point. So sometimes you do have two solution points. Sometimes you only have one solution point if your vertex is that x-intercept. And then sometimes there's no solution points. That's if your parabola is just too high, that vertex never touches that x-axis. There'd be no solution points because, again, this is your x-axis, this horizontal axis. So your solution points are places your parabola touches that axis. Zero product property is often used in Algebra 2 when solving equations. Basically, if you have a product equaling 0, A times B equals 0, then either A equals 0 or B equals 0. That has to be true. There's no other way. So for example, if I know the binomial x plus 8 times the binomial x minus 9 would equal 0, I know either this first binomial has to be 0, and you can set it equal to 0 and solve. By solving and subtracting 8, I do get that solution point of -8. And the same thing can happen with my second binomial. Maybe the x minus 9 is what is equal to 0. And when I add 9 to solve that, I get x equals 9. So either -8 or 9 would have to be the solutions for x for that product to equal 0, because the zero product property. What do you think the solutions would be for this answer? It'd be x equals -3 and x equals 7, because you would set each binomial equal to 0 and solve. Those are called roots, they're called solutions, they're called x-intercepts, and they're also called zeros. All right, what about this one? I'm guessing they factored using the AC method to get something like this. So either my first binomial has to equal 0 or my second binomial has to equal 0. If I set my 2x plus 3 equal to 0, I can subtract my 3, and then I can divide by 2, so it'd be -3/2. For the next one, I would set my 3x minus 5 equal to 0. I would start by adding 5 on both sides, getting 3x equals 5, then dividing both sides by 3, and that would be 5/3. So you can get to the point where you can kind of do these mentally. You would take the opposite of the second number and divide it by the first number. So +5/3, -3/2. Opposite of your second number divided by your first number. All right, let's try this. It says, what are the roots of this equation? X squared minus 5x minus 36. I'm looking out front at my A value here and there's nothing. So this is just going to be the old-fashioned factoring method, my favorite, the very first one we learned and the easiest one to use. Can you think of the numbers that multiply to -36 that add up to -5? Those numbers would be -9 and +4. Now, don't be tricked into choosing -9 with +4. We're trying to get the solutions here. So I set each of my binomials equal to 0, and I proceed to solve. I would add 9 in this first one to get x equals 9, and I would subtract 4 in the second one to get x equals -4. So +9 and -4, C, is actually the choice that we would be interested in. All right, take a peek at this next one with me. We are solving. This time I'm noticing that 3 out front, so I'm going to be using that AC method that we just learned about yesterday. So I will write my 3x squared, and I'll leave some space, and I'll write my -8. Those are my A and my C values. I'll multiply them together to get -24 and replace the 8 with a -24. I'm going to need your help. What numbers will multiply to a -24 but add up to 10? Did you go with a positive 12x and a -2x? So using my grouping method, I've got my blue group and my green group. My blue group, I'm thinking my common monomial is 3x, leaving me with x plus 4. And in my green group, my common monomial can be -2, and that would leave me with that x plus 4, so that my groups match. So to finish this off, I hope I have enough space here. I'm going to put the 3x and the -2 in a brand new group, but merge my x plus 4 groups. And then we need to finish and solve. We're not done yet. So we set our 3x minus 2 equal to 0, and we solve that. And we set our x plus 4 equals 0, and we solve that. So my one solution is -4, but my other solution is 2/3. All right, now this can be a little bit tricky. When you are asked to solve with factoring an equation that looks like this, you're not quite ready for factoring. You need to make sure everything is set equal to 0 before using your factoring. So let's subtract our 4p over. And let's add our 5 over so everybody can live on that left-hand side of the equal sign, and we can be set equal to 0. So it'll be 5p squared minus 20p plus 20. Now, one thing I notice on this problem that we haven't quite seen often is there's a common monomial. So I definitely want to remove my common monomial before deciding if it's going to be the old-fashioned method of factoring or the box method of factoring. And the common monomial I'm seeing is that 5. So let's divide everybody by 5. We'll have p squared left, we'll have a -4p left, and we'll have a 4 here. And then I'm pleasantly surprised by seeing it's just going to be our old-fashioned method of factoring. So what numbers multiply to a +4 but add up to a -4? It'd be -2 and -2. So really, the solution is only going to be p equals 2. And you don't need to list it twice. It is called a solution with multiplicity too because it's a double solution or double root, but we can just list it out once. All right, I think we have a common monomial again. What do you think the common monomial is? If you answered 3, you are a math scholar. So pull out that 3. It'd be 2p squared here minus 1x here. And what is 63 divided by 3? -21 here. So it does look to me that we're going to be doing that AC method again because of this 2 out front here. All right, so we're just going to leave the 3 out front. It's really not going to affect our solution at all. I'll have my 2p squared here, my -21 here. I'm going to go ahead and multiply those together to get a -42 and replace my -21 with a -42. Now, what numbers will multiply to -42 that will add up to -1? I think we should go with -7x and +6x. What do you think? -7 and +6 add up correctly and multiply correctly. I never have enough space on these. All right, I've got my green group here and my blue group. My blue and my green, said that backwards. Leaving my 3 out front, I would have a, why do I have p's and x's? What am I doing here? I should have had x's all along. Nobody corrected me. Yeah, I'm here by myself. There, that looks better. Okay, so I think the common monomial in that first group is just an x, leaving me with 2x minus 7. And in my second group, let's go with a +3. such that we can have a 2x minus 7 left. Abracadabra, make our group. So we will group the x in the 3 and the 2x minus 7 will merge. All right, we are solving. Can't forget what our goal here was. To solve this binomial, let's just do it mentally. You get -3. And to solve this binomial, you get positive 7 over 2. Because you'd set it equal to 0, you would add over your 7 and you would divide by 2. That took a long time. Whew, tired. Seeing how many more we have. We're already at 10 minutes. Let's just jump ahead to this word problem here. The area of this rectangle is 24. Solve for x. So to do area, we're going to kind of group that length. We're going to kind of group that width. So here's my length. Here's my width. And I'm going to set it equal to what they told us the area was, 24. Now you might be wondering, how are we going to solve this? We actually have to FOIL this all the way out, get the 24 on the left-hand side, and then refactor it. So that's going to be fun. So let's do our FOIL. First is x squared. Outside is -6x. Inside is -8x. And last is positive 48. When I combine my like terms, I'll have a -14x here. But let's subtract over this 24 to join the 48. Okay. I did just realize I had a mistake with my work. A positive 48 minus 24 is a positive 24. Now we're going to be successful finishing this problem. I was looking at it and I was like, wait a minute, but then it came to me. All right, you can always learn by making mistakes. It helps your brain grow. Mistakes are a good thing. So what numbers multiply to a positive 24 that add to a -14? Did you figure out the numbers? It's -12 and -2. Beware of the double negative. Making the solutions for this math problem, positive 12 and positive 2. Now we need to go back and think about this. Let me view full screen here. These are dimensions of a real life object. Dimensions have to be positive because you cannot have a negative width. So like sticking a 12 right here would give this dimension 4 units. And sticking a 12 here would give this dimension 6 units. And 4 times 6 would give me that 24 area. Now the trouble is, if I would try putting a 2 in for x or a 2 in for x, I would get negative dimensions, negative lengths, and negative widths. And that can't happen. So this is not an answer we would want to include. 12 is the only solution that would work. So thanks for joining me for my video today. Hope you had a fun time and hopefully you're having a happy day and you have something fun planned for later today. Bye.